Hypothalamus artificial intelligence. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents its services for the optimization of truck transport systems. The mathematical models of high truck transport systems advanced optimization correspond to a set of algorithms used for the planning and scheduling of transport operations, of raw materials, parts, final products, goods, and people, at urban and regional level. The main characteristic of the models is that they can be adjusted to special business rules to produce artificial intelligence and mathematical programming solutions specific to each client. Predictive analytics and data interpretations. Understanding what happened is a great starting point. Diagnostic analytics seeks to answer that question. With a strong focus on past performance, this analytical process commonly gets used to determine the causes leading to the supply chain's current state. The result of transportation analytics often helps to interpret data into something easier to share and apply throughout the transport network. This form of analytics is where the meaningful gains of process improvement begin. Advanced analytics in logistics and transportation implies demand prediction, dynamic pricing, efficient routing, capacity planning, transparency and control performance, and minimum cost operations. Building a transport decision support system, DSS, involves coordinating multiple mathematical algorithms and multiple data processes. The starting point is the asset management system that stores the resume of the vehicles and the maintenance processes. Two models support for transport decisions, they are demand medium and short term, and maintenance policies of spare parts. From the historical information of the vehicles, and possibly from other external sources, the process of prognostics and health management of the trucks, known by its acronym as PHM, must be carried out. Its purpose is to analyze the behavior of the components of the assets for maintenance purpose. The next step is vehicle operations and maintenance planning, whose main result is to determine the vehicles that will go to maintenance and those that will go to operations. Finally, the models must specify the schedules of drivers, vehicles in operation, and vehicles in maintenance. Normally, the models required to define maintenance operations are travel aggregate assignment, it defines the trips to be made, without license plate identification. Vehicles detailed assignment, it defines the truck and trailers that will be assigned to each trip, and driver's assignment to vehicles, it defines the crew that will go in each vehicle. Regional planning involves defining two types of travel. Loaded trucks, transport merchandise associated with shipments. Empty trucks, travel expressly to pick up merchandise. The case of trailers is similar. The basic model for the construction of the models is the so-called VRP, vehicle routing problem, which has the following basic characteristics. Attention and time windows. Capacity limits on weight, volume and/or value, and route cycles. Taking VRP as a reference, all models are adjusted to include the specific characteristics of each user. The truck's transport systems optimization mathematical models, available in high, are presented below. Urban routing is a set of algorithms for collection and/or distribution processes in cities and conurbated areas, that include the allocation of the orders to be delivered, which is handled at the level of the boxes that contain the products. Regional routing is a collection and/or distribution processes, including speed vehicle optimization. It implies the design and implementation of a set of mathematical models to define routes of clients' services, and assign trucks and van-type trailers to routes. The models include single trucks and empty trailer movements, to coordinate services across multiple regional offices, where goods are delivered and/or loaded. It is oriented to regional transport companies and/or LTL brokers. Transport of cash and values includes vehicle routing and assignment of crews. The set of mathematical models defines routes of clients' services, assigns vehicles to routes, and assigns crews to vehicles. For the type of transport, this type of model must conform to multiple end-user business rules, which reflect security policies of the transport company. Due to the nature of the operations, for safety reasons, the operation of the system involves the permanent rescheduling of activities, crews and routes. Waste collection process has special features, since its solution involves assigning the routes in an integrated manner, for a planning horizon of multiple days, for example, a week. The complexity arises when it is considered that the routes must meet the demand following multiple business rules, specific to waste collection. The end-to-end process can be defined based on the following steps. Determination of solid waste collection sectors. Determination of frequency and visit shift for each of the sectors. Allocation of vehicles to sectors and determination of the intersectoral collection route for each day and visit shift. The waste collection routing connects residential users, industrial and/or commercial users, transfer stations, and treatment plants. Transport of mineral and mining complexes includes multimodal transport systems, shotcrete application, blending of materials and other activities. The complexity of mining operations complicates mathematical modeling since in many cases, in addition to truck routing scheduling, it is required to coordinate multiple teams, for example, mechanical and hydraulic shovels, shotcrete coating equipment, etc. Additionally, it may be necessary to coordinate the work fronts with the heap formation processes, to later prepare the blending, that are required by the mineral refining plants, and/or by the commercial agreements. Distribution of gasoline and other oil and gas products between terminals, service stations and industrial clients. A mathematical model of distribution of petroleum products or similar should consider the following constraints. Delivery time windows, tank trolley capacity, distribution of tank trolley capacities in multiple compartments, product availability at service stations, product availability at terminals, load capacity of cargo islands, fillers, work shift, and driver assignment. The result is the scheduling of activities by filling pump, filler, tank car, end user and drivers. The problem of human resources transport, collection and distribution, perhaps corresponds to the simplest routing problem that must be faced, since fixed routes must be established, the same for every day and the different shifts. Under typical conditions, routes are calculated offline for long periods of operation, months, semesters. On a daily basis, it may be necessary to solve contingency problems that involve partial rerouting of established routes. It has as restrictions: collection and distribution of personnel in a maximum time, and vehicle transport capacity, less than truckload revenue management and operations optimization. An LTL network broker is a transport company with a fleet of trucks, which serves a sequence of delivery requests, received either by phone, mail, or internet. A DSS for LTL revenue management must have the following models. ML-like models are used: demand winning bids, supply winning bids, and link LTL network dispatch and revenue management. To determine the suitability or not of an offer, SVMs, support vector machines, is used to segment the winner's bids of the loser's bids. This applied to prices offers to the clients, load generators or transporters. The central problem of LTL, less than truckload trucking, business is to choose the most profitable transport service demands, for direct long-haul routes, or for multiple pickup and delivery routes, and fix the offer price for requests for transport services or accepting an offer previously agreed in a bilateral long-term agreement. The decision support system for an LTL broker is similar to that of a standard carrier, but must include dynamic pricing modeling. Speed modeling is very important in long-range travel. In state-of-the-art cargo transport vehicles, the engines are electronic, digitally controlled, with telemetry capacity from the nearby environment. This autonomous capability may be called optimal short-range control. However, there is another level of vehicle operations planning that is long-range, and related with the total journey. The problem of optimizing energy consumption, gasoline, diesel, natural gas, propane, or electricity, is complicated because the energy function is nonlinear, and depends on factors that are the result of the decision-making process, such as the load and the position of the truck in any moment. Additionally, exists exogenous factors that define fuel consumption, depending on the vehicle and the route. These may be divided into static, for example, slope, rugosity, etc., and dynamic, that depend on traffic and route weather status. High can incorporate the modeling of the speed of the vehicle as one of the decision variables of the routing model. The fundamental idea is that the arrival time is the result of coordinating time windows and fuel consumption, so as to minimize the cost of fuel throughout the total journey. In this way, the truck will arrive just in time, not a minute before or one after. The vehicle's maintenance optimization objective is to minimize the maintenance cost. The model considers assets, trucks, maintenance and operational activities planned jointly, PHM considerations, and scheduling of maintenance tasks on a several weeks horizon, including allocation of staff and equipment, and sequencing and timing of maintenance tasks. Hypothalamus Artificial Intelligence is the creator of artificial hypothalamus and autonomous real-time distributed optimization. Thank you for your attention.